The one and only multiverse presents a grand unified theory. Atomic, cosmic collisions. Subatomic particles. Splitting the atom. Galaxies. Neutron stars. Black stars. Primal space, black star supernova. Web page and video are not AI generated. Your host, Richard E. Noer. Colliding particles and bodies. What happens? Outcome. Result. 1. Proton, proton. Electron, proton. Electron, electron. What you get are the well-known subparticles of quarks, leptons, bosons, hadrons and fermions, QLBHF particles. B. These structures are fractured particles, and are not the building blocks of the cosmos. They are splinters of the horn torus bodies that make pen particles. Pen particles are proton, electron, neutron and neutrino. 2. Neutron, proton. When a neutron meets a proton, energy is key. Lower energy between each will allow them to bond if conditions are just right. Extreme energy collisions could destroy them and create QLBHF particles. B. This is so important, because if this event was not possible we wouldn't have any atoms or a universe, multiverse as we know it. We are so lucky that neutrons and protons bond. 3. Neutron, atom. This is what can create an atomic explosion. Atomic or neutron bomb. When neutrons split the nucleus of an atom, it changes the number of atomic nuclei and quantum fields. This in turn produces multiple pressure waves in these fields, along with an excess of dark matter particles. The Q fields that are compressed because of increased pressure, is what produces the high energy of light, heat and radiation that we all have observed. Bang! B. Not only can an atomic splitting create devastating explosions, and QLBHF particles, it also can create controlled nuclear reactions, that supply electricity for millions of people and keep them warm and safe. 4. Atom. When atoms are close together and their quantum fields are compatible, they magnetically bond to form all the molecules of the universe. B. This is another basic event that without it, we cannot survive. This is because there would be no air, water, or earth. 5. Planet, asteroid. This can be a catastrophic energy release depending on the size of the asteroid. If the asteroid is moving fast enough, anti-gravity will destroy it, and cause an explosion. The explosion magnitude is proportional to the asteroid's DMI. B. It is theorized that an asteroid, Earth encounter ended the dinosaurs' existence. Although no one was around to record the event, the collision was most likely the cause. This is because of an iridium layer that was discovered throughout the world. Iridium is common with meteor impacts. Both events were linked with the same geological timing, with a crater that suddenly formed off the Yucatan Peninsula. 6. Planet, comet. This also is not good. It is the same scenario as the asteroid. Invading comets can explode above ground or upon contact, thus creating enormous damage. An extremely large one could cause an extinction event. B. I don't know if you remember when a comet hit Jupiter. It was a spectacular event and shows off the vulnerability of planets. The energy released was enormous and was recorded live from Earth. Wow! 7. Star, asteroid, comet. An asteroid or comet colliding with the Sun is the least problematic of the high-energy encounters in the solar system. This is because the Sun is so vast the energetic encounters would be smothered by the Sun, unless something real big came into the system. Like a neutron star. Then, watch out! B. Our beloved Sun not only warms us up and supplies energy for life, it also keeps us safe from rogue asteroids and comets from space. It is like a giant solar system cleaner. 8. Star. Now it gets interesting. In a binary system of a white dwarf and a large regular star, the white dwarf can steal plasma from the larger one. When the dwarf reaches the right density, the gravity-ripping currents from space can cause a nova explosion. B. Star-star collisions are rare, and have countless results that depend on size, spin and density of the stars. b. On a cosmic scale this would be a relatively slow encounter because of gravity and centrifugal forces. Binary stars can be similar or quite different. One can dominate the other and their existence can be short-lived or go on for billions of years. They can merge or share plasma, it all depends on the closeness and size. They usually are born at the same time. That being said, there are just too many variables to predict an outcome, each system is unique. They can merge, separate, or tear apart, it all depends on circumstance. 9. Galaxy. Galaxy. This is a beautiful dance that gravity creates between black stars and their many companions. Galaxies come in multiple formulations, big, small, millions or billions of stars. When they do come together, star and matter collisions are extremely rare because of the huge distance between all bodies. Catastrophic explosions because of collisions are rare. It usually takes many passes before a galactic merger can occur. b. This is a major part of galaxies becoming larger. In cosmic evolution, as time progresses, some galaxies move further apart, but others don't. Now, in parts of the cosmos, some of them have started to merge. This is because their black stars are much stronger and bigger. As parts of the cosmos loses energy and magnetism, the black stars will have more pulling power, and parts of space will stop expanding. Each structure in polarized space will be forced to seek out the closest gravitational point. There is only one cause of this phenomena, it is the existence and pulling power of black stars' polar and ring gravity, in the dark matter medium. 10. Neutron star, asteroid, comet, planet, star. Now we come to the very dense high stored energy of the neutron star. Energies from here on, are going to get huge. When asteroids, comets, planets, stars encounter a neutron star, the gravity is so strong they break up, but not to the universal particle level. Debris that is left behind is flung back out into space because neutron stars are a closed system, and don't absorb matter. These encounters are most likely to create some of the X and gamma radiation that we have observed. This is because of the high level of the ripping magnetic currents of gravity. b. If asteroids, comets, or stars are caught in the gravity pull of a neutron star, their fate is sealed. This is because neutron stars possess a gravity level 3. When they encounter this force, as they get close, a tearing effect is introduced. Depending on the DMI of the approaching structures, will determine how long they will live. The neutron stars can produce X and gamma rays, also an accretion disk and polar jet. 11. Neutron star, neutron star. When neutron stars encounter each other, contrary to popular belief, there is no catastrophic energy release. This is because, just like magnets, they merge and don't break up. The remarkable thing about neutron stars are, they have no internal protons or electrons. And finally, at the basic level of the star's interior, it is the energy of spinning universal particles that has created the third stage of gravity. That's why approaching bodies break up, but not to the subatomic level. The level of universal particles. b. The takeaway from this encounter is, neutron stars are closed systems and don't consume matter from space. They have third-level gravity and cause large disturbances in their environment, and are a force to be reckoned with. I certainly would not want to visit one. Now for something that few people know about or have theorized about. They set the stage for even greater energetic events. 12. Neutron star, black star. Because neutron stars have third-level gravity and black stars have fourth-level gravity, the handwriting is on the wall. There most certainly would be a catastrophic encounter. The neutron star can get much closer to the black one. When this happens, it gets quickly torn apart. X and gamma rays, heat, light, and high-energy pulses, along with high compacting of UDMP fields, are a certainty. b. If a neutron star meets up with a black one, oh boy, hang on to your hats or spaceship. This is the biggest energy release in dark matter space. The neutron star will be ripped apart to the dark matter particle level. Accretion disk, X, and gamma rays are produced, along with a polar jet, but wait. Just when you think this is the ultimate catastrophe, there is more to come. 13. Black star, asteroid, comet, planet, star. Black stars are common throughout the universe, multiverse. There are stellar and galactic ones. When they encounter any objects with less gravity, the approaching body is doomed. This is because black stars have a level 4 gravitational ripping force. They tear apart these bodies to the UDMP level and consume the material. This in turn increases the black star size and pulling power. Of course, the dismantling and consumption releases enormous amounts of energy that once belonged to the approaching structure. B. The result of dismantling a stellar body by an encounter with a black star, produces an accretion disk, an area void of light, and a polar jet. A powerful, polar anti-gravity stream. Also, there is the very fast vibrations of X and gamma rays. This is because of magnetism and its pulling, pushing spin energy as the structures of dark matter particles get separated. The spinning particles that are left behind, are pulled into the black star. The black star is now bigger and has increased its potential energy. Wow, how come I never heard of this before? It is because there is a stalemate produced by the Standard Model, and a misunderstanding of observable science, relativity, evolution, mathematics, and logic. 14. Black star, black star. When black stars encounter each other, contrary to popular belief, there will be no mind-numbing explosion. Just like neutron stars, both have the same density mass index and fourth-level gravity, so they can only merge. B. A black star running into another one, is not the horrifying event that people envision. It is a high-energy encounter, but with a relatively low disturbance of surrounding space. In fact, there was more energy being spent before the encounter. Because they have the same DMI, and both are at gravity 4, they don't come apart, they merge. This event has been observed by the LIGO experiment. It seems a black star merger ends with a chirp, not a bang. What? Yes. Look it up. 15. Black star, primal universe. We saved the best for last because it is the ultimate encounter. With the collapse of some of the dark matter space, and if there is a black star embedded, there are only two things left in this part of the cosmos: multiverse. Primal space and a universal black star. It is a certainty that both extremes will collide. When this happens, parts of the multiverse changes. The black star loses all its gravitational attraction and containment. It releases all its matter and stored energy and replaces it with XP dark energy. A catastrophic expansion occurs, new particles are born, and a pristine area is created. The new area has no gravity. B. This is the ultimate energy release. It reforms parts of the cosmos, multiverse. Primal matter and primal space gets converted when forced to spin by a black star that has lost all its gravity. You guessed it, this is the energy of a black star supernova type 0. It creates pristine dark matter space without any gravity. This means that parts of the multiverse must start from scratch, and a new timestamp has been created. There are no bodies or structures in the area yet, just the expanding multitudes of tiny spinning particles. It is the perpetual ending and beginning of dark matter, space, and the never-ending evolution of existence. Your host, Richard E. Noer. Young me. Mini me. Email, noerastronomy@gmail.com. Here in a multiverse, our goal is to find the cosmic truth. No matter where, or how far it takes you, the universe truly does unify. If you get the basics right,